Hello everyone, this is the second video clip for introducing new electro-hydraulic system of Doosan products. Please be aware that this video clip is for our employees and partners only. Okay, so what we are going to see in this presentation is more details of VBO, virtual bleed-off system, and FEH, full electro-hydraulic system. Location of each part of VBO system is shown in this modeling illustration. As same as before, EPOS is located at one behind the chair, and the major difference is calculating the signal received by individual the pilot pressure sensor and sending it to the pump EPPR and also the bypass cut EPPR. There is a different type of regulator on the pump. And in this operation, EPOS get a signal from the angle sensor, which means the calculating real-time flow rate of the pump. So we can say the components which has been added to new VBO system are the pressure sensors of each pilot line and angle sensor of the pump, and bypass cut EPPRV and also pump EPPRV. To briefly introduce the joint bracket pressure sensors installed, it is located next to the cylinder block, which can be seen on existing mechanical equipment as shown as figure. As described in each sensor, the pressure of each pilot line is measured through the sensor and consequently used to control the system. First, let's look at the controlling way of the VBO system. When the pump is running, it must be determined at what level and how much flow is emitted, which can be checked by the PQ curve. The three main control methods applied to the pump are flow control and power control and power shift control. In other words, these three methods are to be applied to the Doosan excavator's pump. In terms of functionality, previously it was designed that the flow control and power control are mechanically controlled, and only the power shift control was controlled by EPOS. However, the current VBO system control flow control, power control, and also power shift control electronically. If you look at the graph on the right, it is a PQ curve of how much flow and pressure can be reached. Next, P is a system pressure that relief valve limits to 350 bar. If you go over it, the relief valve leaks flow rate by the protective circuit. The maximum flow rate Q is restricted by the pump's angle of switch plate by the stopper. In the meantime, we call it power shift control that optimizes the matches of required output. If you take the closer look at the features, and you'll see finally flow control, system pressure control for additional function, and the power control part, and the power shift that controls the movement of the yellow line on the graph. The differences between Negacon and VBO system can be compared as follows. First of all, in terms of advantages, the Negacon system can be controlled by the power control even if the control valve is broken. But the downside is that there is a misreaching area that does not control. On the other hand, VBO system can control as the same as the equivalent power line. It can also be programmed for required load filling or controllability through a virtual bypass line. We evaluate it as more advanced system, but the downside could be increasing complexity and cost as many sensors are attached. However, it reduced the unnecessary flow losses in terms of cost, which result in about 3 to 7% of reduction in a fuel consumption. Okay, so let's learn more about EPPRV and pump of previous system. You've already seen the EPPRV as a single component itself on current equipment. The introduction of VVO system will only change the way of processing, but as you know, EPPRV has the same basic mechanism. EPPRV is a valve that controls pressure related to the input current as a key part of connection between electricity and hydraulic pressure. Spool exists inside a valve, and the system is maintained by finding the equilibrium point at which the pressure generates from the P and installed spring force and opposite the magnetic force are equal. Okay, if you look at this figure, you can see that we operate through a pressure control pump. It has a pressure ratio of approximately 1 to 12 between A and B. For example, if 10 bar applied on A, then 120 bar applied on B due to the relationship between area and pressure. If B add higher than 120 bar, the spool will move to the left. As a result, the larger chamber losses is flow to the tank, and the angle of the pump will be increased, which increase the flow rate. Conversely, if B is lower than 120 bar, the spools move to the right. Therefore, the flow rate of the small chamber is drawn to the tank, and the angle of the plate is decreased, which reduced the flow rate. Okay, let's move on to FEH system, stand for full electro-hydraulic system. Let's check the concept and major components, major logic, and effect analysis. Okay, let's talk about FEH concept. When we compare it with VBO, then VBO is aided by an electro-hydraulic pump, but FEH system is just added by electro-hydraulic main control valve. To put it simply, in case of excavators, when discharging the 100% energy, the loss of the pump is usually considered as a 15%. And importantly, MCB side is about 55%, and the other remain actuators are about 10%. Afterwards, only about 20% is to be used for real work. Consequently, we can say FEH system has been taken to reduce the loss of this main control valve. Normally, there are several actuators acting on one pump. For example, running a boom, arm, and bucket at the same time causes a lot of flow toward on a lower side of cylinder. This can cause problems with only certain operation on low load side, so complex operation can be a problem. So reface could be installed on the lower load side so that it create pressure resistance. We call it simply priority valve. It has a role in creating similar speed for complex operation, which cause also loss in a MCV side. However, there are times when priority valves are not needed for each operation. Therefore, this FEH determines the operation, load condition, and user's intention to control the valve and improve the efficiency through the spool displacement. For details in MCV, each spool has PC area, which is connected from pump to cylinder, and also CT area, which is connected from cylinder to tank. We will call it simply PC and CT. For example, if the open CT area is large and front operation speed is fast, then cavitation probably appears because there is a limit of supplying flow rate to the cylinder while the weight accelerates flow rate to the tank. So as a concept of design, it is designed to set the CT area small to prevent cavitation. In other case, of excavation, when working with the actual inlet supply flow, so if the CT area is small, the pressure get increased and consequently get unnecessary delta P, pressure resistance. For this reason, existing old-time Megaton excavators sometimes lose energy due to back pressure during the excavation. FEH system has developed with a logic that it can improve the fuel efficiency compared to the conventional excavators by controlling CT area variably according to the operation. And then let's check how FEH hardware configuration has changed compared to the VVO. Since the VVO system is electronic only with a pump, the hydraulic joystick is installed and pilot hose is connected, and this method controls the VVO pump regulator through the EPPR for pilot pressure value. But the FEH system uses an electric joystick, and of course this design makes a hydraulic oil not to enter the cabin. In this system, operators are unlikely to experience an overheated joystick or cabin heating problem because there's no any hydraulic oil inside of the cabin. The electrical signal controls the EPPR of MCV individually and electrically. So in MCV, you can see that all the pilot caps are gone. You can see these pilot caps and all the guns, and each EPPR valve here is applied as shown in the figure. In this diagram, there are electrical joystick pedals and slave control and master control connections through the CAN communication. This electrical signal calculated through the FEH logic in master control is direct to the individual EPPR, final individual EPPR through the slave control. As a result, each spool moves through the EPPR here. As explained on the previous page, on crowd, bucket crowd, and boom crowd, this self-movement operating by weight, the pilot pressure for each of these is measured through a pressure sensor and adjust again before shipping normally. Although PAPT could be replaced by electrical signals with FEH system, but PAPT pilot line also was maintained in a consideration of safety to determine the actual physical malfunction of the spool. Thus, finally, only 5 pilot pressures enter the MCV. You can see that there are 2 types of EPOS as in this modeling figure. One is the master EPOS and the other one is the slave EPOS behind the cabin. In the aircraft system, if get 60 bar and boom get 150 bar through the joint spool, and then each pump flow 100 lpm and the other 100 lpm may not activate the boom, instead activate the arm only, because the flow goes always low load side, considering load as a resistance. So as the right figure, we put the orifice here and to make the complex operation, and we calling it priority valve. But in this case, still there is a problem because the pump 1, pump 2 goes to the 150 bar unnecessarily, because it is to meet the required maximum pressure 150 bar for activating the boom. However, when we look at the FEH system in a complex operation, there is no joint spool, so we can say we disconnect the boom to spool and arm to spool. In this case, pump 1 goes to the arm cylinder only, and pump 2 goes to the boom cylinder only. For the complex operation, in this case, in this FEH system, pump 1 needs 150 bar, but in FEH system, we just giving them 60 bar instead. So we are not can say we can save up the energy compared to the Negacon system. For your better understanding, I attached some document, and you can take it for understanding the mechanical priority valve. There are many types of priority valve. First, using a pilot pressure and or pilot proportional spool type or fixed orifice type. You can just take the details here. Okay, it is another explanation with the hydraulic circuit. In an Negacon system, there is a priority valve here as shown in the figure, and you can find the enter past purple line and the yellow hydraulic line in the parallel. Briefly, you can understand this as an equivalent hydraulic circuit here. As compared in FEH system, priority valves were deleted and instead implement the valve function through the software control in arm to spool. So the fuel efficiency has been improved according to this new logic. For FEH system, we theoretically calculate the area of orifice with the previous Negacon system and determine it by the validation test. As I explained earlier, that VV logic reduced the current pressure loss by controlling the priority valves, and advanced system FEH was explained how logic is actually implemented for preventing actual cavitation. Again, in case of uncrowd, the CT area is very important to understand. We need to control the area of CT, but for the low load operations, the area of CT needs to be decreased. So that is an important point. Conversely, for the high load operations, the CTA area must be increased. So in this FEH system, we made a software and put the logic in the EPOS, so EPOS control the spool electrically. And as the last session, I would like to share the result of actual testing with FEH system. This graph calculates the required power of the pump of the existing Negagon equipment at the top. So this graph showing the Negagon system, and the actual machine's power was controlled in the case with this red line. The existing Negagon is subject to get a power controlled at excavation, because if the pump discharge rate is 100, then there is a limit to the power available, so the discharge flow rate is limited. However, if you compare with the second graph of FEH case, the pump pressure decreased by the controlling the CT area. So one part of this A section does not have the power control, so pressure is low, and as a result it saves this amount of energy. The speed of work will be increased as power reduced. And when you look at the B, preferential distribution prevented this pressure loss, so cycle time was shortened, and finally increased the fuel efficiency as much as E by increasing crowded reason. So this is the end of the second presentation, and for the third presentation I'll prepare for how to use the DMS calibration for the VVO system.